Hello dear students and teachers. First of all, let me introduce myself. My name is Arman Bekpolatov and I am physics teacher of Nazarbayev Intellectual School of Chemistry Biology in Shıмкent. So now I would like to start with acquainting you with flow of my lesson. And today's topic will be about equation of one-dimensional motion with constant velocity, and in other words, topic will be related to the uniform motion. Okay, our lesson has 4 parts, as you can see, and first of all we'll start with checking homeworks. Then in next part I will say to the students the lesson of objective and today's topic. After that, as you can see, we have main part where we will discuss this today's topic, and in addition to this we'll solve some problems. And finally we'll have conclusion where we'll do some formative work, and our lesson will be finished by this. Good afternoon, students.
Good afternoon, teacher.
Okay, so let's start our lesson, okay? Now, before starting lesson, before explaining our today's learning objectives, I want to review the home task, okay? So what was the last topic? Yes, you are right. It was this topic. Now I have some questions for you to just review and remember what we learned, okay? Now, first question is, what is the scalar quantity? Who wants to answer? Bota?
A quantity containing a magnitude but doesn't involve direction. For example, mass, distance and temperature.
Is a quantity which containing both magnitude and direction, for example, velocity, acceleration and displacement.
The similarity between vector and scalar is that they have a magnetic type, but a vector also has direction. This is the differences between vector and scalar.
This is the total length of path and it has a node direction. Displacement is the joining of initial and final points of path with straight line, so it has direction.
Let's draw the picture. We draw 2 points from A point to B point. We draw a path. This is distance. We draw a line. This is displacement.
So students, just we checked with your homework and reviewed some topics before previous lesson, and now let's start our lesson. So as you can see, our today's lesson objective is a learning equation of motion in one dimension with constant velocity. And guys, before saying our topic, I would like to divide this objective to the 4 parts to achieve this objective. And now, first of all, look to this. First we'll start learning by types of motion, where we'll completely describe what is the motion and what kind of types of motion we have. And then we'll pay attention one type of the motion, which is uniform motion, and after that we'll learn some parameters of uniform motion such velocity, displacement, distance and speed. Then we'll start to learn about average velocity and speed, and finally we will draw the graph of uniform motion. It's a short review of our today's lesson, and I think it's clear for you. And let's start by explaining types of motion. Okay students, we just reviewed our home task and remembered something from last topic, and now let's start our today's lesson. By this I mean we are going to learn about one-dimensional motion. One-dimensional motion in a straight line, and this straight line is called as x-axis, or some case x number lines. And as you can see, car could move to the right side or the backward. And if car moves to the forward, it's called positive movement. And if it's positive movement, it takes larger and larger x coordinates. So if you have larger x coordinates, it means we have positive displacement and positive velocity. Okay, now let's talk about negative movement. In negative movement, it takes smaller and smaller x coordinates, and if it's smaller, we have negative displacement and negative velocity. Okay, let's talk about constant velocity. In constant velocity, car speed does not change and direction also does not change. In addition to this, moves equal distance during equal time intervals. And this car is moving with constant velocity, and let's talk about that. It has greater x coordinates and it has positive movement, and we can prove it by this example. Let's take x1, which is 2 meters, and x2 is 5 meters, and let's take the changing of this displacement. Okay, here x2 minus x1 gives us 3 meters, and it means it's a greater displacement. Okay, in other words, it's a positive displacement. Okay guys, objects move through equal distance during equal time intervals. That is what we mean by constant velocity finally. And now let's talk about second type of motion, which has constant acceleration. Okay, in case of acceleration, speed increases and direction does not change. In addition to this, it moves over a greater distance as equal time intervals pass. Okay, now look to this example. In this example, car is going faster and faster. It means it has acceleration. And notice that object covers more distance in later time intervals than in early ones. Okay, so as we said, the car is traveling faster than before. When object velocity change. Okay students, we just watched a video where I explained what is the constant velocity and what is the acceleration. And now look to this presentation. When we have constant velocity, it's called as uniform motion. And this is our definition of uniform motion. When equal distance is covered in equal interval of time. We just said about that. And second type of the motion, non-uniform motion. And in non-uniform motion, we have acceleration. But students, I would like to say that we are not going to learn non-uniform motion, and I want to not pay more the close attention for that. And because our today's topic is uniform motion, okay? And now let's go to the next presentation. Okay, in next presentation we have rolling balls. And the rolling balls is an example of uniform motion. And students, I also like to pay attention to that. We have speed in some case, the word speed, and we have word velocity. And before, when we reviewed our home task, we said that speed is a scalar quantity and vector is velocity is a vector quantity. And we'll learn each speed and velocity separately, okay? And now let's start learning by speed. Okay guys, look, we have a rolling of ball, and the ball started to roll, and it started from the point 1 and continued until the point 5, as you can see. And for each second, the car moved 2 meters. And the distance was same for each second, because we have what? We have uniform motion. It means we have constant speed. And now, Okay, let's look to the definition of speed. Speed, how fast an object is moving, okay? In other words, we should find how fast object moved, okay? If you divide 2 meters for 1 second, could we find how object is moved, or how fast an object moved? Yes, you are right, we can't find it easily, and this is our equation of uniform motion for speed. V is a velocity speed, and d is a distance traveled, and t is a time taken, okay? On this case, we can divide just any one of the distance to the time taken, yeah? For example, 2 divided by 1 gives us what? 2 meters per second. And finally, we will have our speed. Yeah. And let's continue in next presentation. Okay, students, we just found the equation of speed. However, we need to find another equation, such as equation of distance or time. By using this triangle, we can easily find other parameters of uniform motion. Okay, there we have distance, which is speed times t, and we can easily change this by that. D is mean, t, time is mean distance over speed, or in next example we should find speed, which is distance over time. And I think it's a very easy way to learn this equation by using a funny method of triangle. Okay, let's go to next presentation. In next presentation, I have some example for you. In this, let's read together this example. A boy covers a distance of 3,000 meters in 10 minutes with a bicycle. What is the speed that the boy rides his bicycle? Okay, guys, we just read this question, and let's look to the solution. What is the information given in this? Distance, which is 3,000 meters, time, which is 10 minutes, and we should find what? The speed, yeah? What is the equation we need to solve this problem? Yes, you are right, V is equal to x over t, or distance over time. By the way, guys, on some cases we can change d, it means distance, with the symbol or letter x, okay? And now let's look to the calculation. Students, I want to say one thing. Don't forget to convert all our units to the SI system, because we needed to have a correct answer. And so, meter is in a SI system, but a minute is not in a SI system. So we should change it. Okay, look here. 10 minutes we should change to the second. So 10 minutes in total, if we convert it, we'll have 600 seconds. Yeah. So let's continue. And by using this equation, finally we'll have what? 3,000 meters divided by 600 seconds. And in total we'll have 5 meters per second. And I think it's we understood this example, and in next part of the lesson we'll solve with you some problems according to that, but the level of the problems will be slightly higher than what we have and what we solved now. Okay, students, we just talked about speed and distance in uniform motion. If you remember, at the beginning of the explanation, I said that we should learn speed and velocity separately if you want to understand uniform motion in a right and excellent way. So now let's talk about velocity, and when we come to the velocity, we should use displacement, because both of them are what? Yeah, you are right, vector quantity. And now, in addition to this, at the beginning of lesson, if I don't forget, Baujan is draw this picture here, and he noted this as the distance and here delta x as displacement. Okay, when we want to learn velocity, we need this picture and also equation of speed. Okay, equation of speed is what? V is equal to distance over time. Yeah, this is equation of speed. Yeah. Okay, if you want to find the speed, we should use distance, and the equation was that distance over time. Yeah, and let's go to the equation of velocity. Okay, guys, the velocity and speed has the same symbol. Okay, but difference between them, one of them is scalar, second one is a vector, and we should know that velocity as a scalar by the line of the head of the velocity. Okay, okay, is equal to when speed is a scalar, distance also scalar, and it means in this case, on this case, we should use what? Not distance, we should use what? Displacement. Here you are right, displacement over delta t. As we took changing of distance, we also should need to take changing of time. Okay, and now let's go to open this equation. Okay, if you open this equation, we can open it like that: x2 minus x1 over t2 minus t1. Here, okay, let's write. Okay, students, sorry for that, I made some mistakes in seconds. Here we should take 2 seconds, 2 seconds, and 2 seconds, because we have constant velocity, and it means the time interval should be equal in each period of time. Yeah. Okay, now let's imagine we have x1 here, and this is equal to 0 meter because car does not start the motion yet. And let's write here for this time of period, for t4, x2 is equal to, I don't know, maybe let's imagine 200 meters. Yeah. And if you want to find the velocity or speed, we can use same equation, and we can think it's like a distance, and we can think it's a displacement. But what is the difference when we use displacement, when we use distance? Okay, if the direction is showed in this example, okay, so velocity, we should find velocity. Okay, now look, we should find velocity. Okay, velocity is equal to delta x over delta t. Okay, as delta x we can take 200 minus 0 and divided by what? If it there we have how many seconds? 2, 4, 6, 8 seconds here. So in total we have 8 seconds here. So finally our answer will be what? 200 over 8. And please use your calculators to find this. You are right, 25 meters per second. Okay, students, don't forget that this magnitude could be as a speed and as a velocity, because both of them has same equation, and difference between them just in velocity we should use displacement, okay? Why we learned this separately? Because guys, in most cases, as you are 9th grade, our problems will be slightly hard. Okay, students, let's talk about average velocity and speed. Okay, before to learn what is the average velocity and speed, let's write the equations of speed and velocity. Speed is a distance over time, and velocity, this is vector quantity, delta x over delta t, yeah? Now, let's say it like that. The car started to travel from point A to the point B, okay? And it achieved to the point B. And car traveled from A to point B in the path which looks like that, okay? And when he came to the point B, the total distance which car passed was 400 meters. However, when he will achieve from point to the point B in a short distance, by short I mean displacement, the driver could achieve this from point to the point B in a short period of time, as displacement is shorter than distance, and it was 300 meters. Now, in total, it took from him, from driver, 15 seconds to achieve from point A to the point B, and from point A, ne alasılar ya? Kişisler ya? Yeah. Okay. So it took in total 15 seconds to achieve, to pass from point A to the point B for driver. And the question is that find speed average. Find speed average, okay? Find speed average. So on this case, we should use equation of speed, distance over time. But remember that distance could be taken as a part here, okay? Part of, I don't know, where you want. And you can just find the so question is that we should find the average speed, okay guys, don't forget average speed. Average speed is mean we should, oh sorry guys, speed. Average speed is mean that we should use what? The total length, yeah. So in other words, if you want to write equation of speed, we should use not just distance, we should use total distance. Yeah, total distance. And which one is divided by total time. And finally, we'll have what? 400 meters divided by 15 seconds. Yeah, because our total distance is 400 meters and it is approximately 26.6 meters per second. Okay, we found the average speed, yeah? But if they ask average velocity, average velocity, and let's write speed as v and average velocity with the straight line at the head of the velocity, okay? Because it's a vector quantity. Okay, on this case, we should use velocity average total displacement, okay? Total displacement. And total time, yeah. So, as you can see, our total displacement was 300 meter. 300 meter. And divided by 15 seconds. In total, we'll have 20 meter per second. Did you see difference between them? But actually this is just example. In other questions we will have another solutions, because in real life, for achieving from point A to the point B will be slightly shorter, because we go to the point A to the point B with a straight line, and we can move with more velocity. It means we can get to the point B in a short period of time.
In my question, distance is equal to 406 kilometers, and time is equal 7 hours. And we must find the velocity. For this, we must convert these parameters to international system. And our main equation is yes. And final answer is 1.6 meter per second.
In my problem, V1 equal to 50 kilometer per hour. V2 equal to 55 kilometer per hour. As we see, T1 equal to T2 plus 2 hour. And we should find T2. Firstly, I should convert this parameter to SI system. 50 kilometer per hour equal to approximately equal to 14 meter per second. 55 kilometer per hour approximately equal to 15 meter per second. 2 hour equal to 7,200 seconds. And as we know, S1 to S2. S1 equal to V1 multiplying T1. And As we know, T1 equal to T2 plus 7,200 seconds. V1 multiplying T2 plus 7,200 seconds. S2 equal to V2 multiplying T2. And we should find T2. T2 equal to V1 multiplying T2 plus 7,200 seconds over V2. Then V1 equal to 14 meters per second multiplying T2 plus 7,200 seconds over 15 meters per second. And then 15 T2 equal to 14 T2 plus this, and T2 equal to for this. We can convert this parameter to hour. It will be 28 hours.
Let's draw a map. So this is my home. This is bus stop. And this is our school. This is bus stop. And this is. So distance between my house and the bus stop is equal to 300 meters. And the time I reach to the bus stop takes 5 minutes. In SI system, it's equal to 30 seconds. Time for waiting is equal to 3 minutes. And the distance between bus stop and school is equal to 18 kilometers. In SI system, it is equal to 18,000 meters. And the time that bus reached to the school is equal to 30 minutes. In SI system is equal to 1,800 seconds. In this problem, we have to find my velocity and velocity of bus, and then find over average velocity. So my velocity is equal to S divided by T, and so how do you see? My average velocity is equal to 1 meters per second. And the velocity of bus is equal to 10 meters per second. If we find the average velocity is, we find it with this formula: S total divided by T total. S total is equal to 300 meters plus 18,000 meters divided by 30 seconds plus 3 minutes. It will be 180 seconds, and 6 meters. So the V average equal to 8 meters per second. Thanks for your attention.
We sent the car. After 7 seconds we took a distance. It was 2.24 meters. So by using equation of velocity we find it. It was 0.31 meters per second. After that we again sent the car, but on this case we measured the speed with speedometer and the result was the same. Excellent and clear. After this lesson, we could achieve all goals. Thank you for our teacher.
Touching the lesson, there were no problem. That's why the lesson was not only clear, but also at highest level. We understood all of the things.
To my mind, the lesson was interesting and had some entertaining sides. And I hope that every our physics lesson will be such as lesson which was today.